In this massive race to build superhuman AI, there's this one giant problem, and it's been hiding in plain sight the whole time. It's a paradox, a ceiling that has kept even our most powerful AIs tied to us, their creators. So how do we possibly break through it? I mean, really think about it. If an AI can only learn from stuff that we humans make, how is it ever supposed to get smarter than us? How could it possibly discover something that we don't already know? It feels like trying to lift yourself off the ground by pulling on your own shoelaces. It just shouldn't work. And that's the bottom line, really. We are the bottleneck. Creating the huge amounts of high-quality data these models need is just super slow and crazy expensive. And that puts a fundamental cap on how smart an AI can get. But what if AI didn't need us? What if it could just teach itself? Well, that's exactly what this brand new research paper called Agent0 decided to find out. It sets up this really cool experiment. Think of it like a digital classroom with just two players. So let's meet them. So on the left, you've got the professor, and on the right, the student. Now here's the really wild part. These aren't two different AIs. They are identical copies of the same base model. They start with the exact same brain, if you will, but they're given two totally different jobs to do. The setup is it's so simple, it's brilliant. The Professor AI's only job is to come up with new tricky problems, basically to design the pop quizzes. And the student AI's job? Well, it's to take those quizzes and try to solve the problems. They're locked in this kind of dance, a game designed to push both of them to get smarter together. And what this creates is this incredible self-improving loop, a cycle of teaching and learning that just runs all by itself. No human data needed. So let's break down how this thing actually works. Okay, so here's the play-by-play. First, the professor bear dreams up a new problem. Then, the student bear gives it a shot, and it actually comes up with a few different possible answers. Now, here comes the really clever part. The professor doesn't get points for making a problem the student gets right, or even wrong. It gets points for making a problem that just stumps the student. And that, right there, that's the secret sauce. The system rewards the professor for creating tasks where the student is the most confused, where it's kind of split 50-50 on the answer. This is the absolute sweet spot for learning, what educators call the zone of proximal development. It pushes the student right to the very edge of what it knows, forcing it to get better. Then, both of them take that feedback and level up for the next round. But the researchers looked at this and thought, you know what? This isn't fast enough. They wanted to pour some jet fuel on the fire. So they decided to give the student a superpower. Just like any of us trying to cram for an exam, the student can get stuck. It can hit a wall on a problem where its own knowledge just isn't cutting it. It's confused, and that's where the learning could grind to a halt. So the researchers asked this really simple but powerful question. What if, when the student got stuck, it could phone a friend? Not a human, but something else. And boom, this is the absolute game changer. They gave the student AI access to tools, specifically a code interpreter. It's like giving a student a calculator for a math test. All of a sudden, they don't have to do all the tedious stuff in their head. They can use the tool to check their work, run a little experiment, and tackle the problem in a totally new way. And this kicks off what the paper calls a virtuous cycle. The student, now armed with this powerful tool, gets way smarter, way faster. And that in turn forces the professor to get even more creative, cooking up even harder problems that you need the tool to solve. And so they both just start rocketing up in intelligence way faster than before. So the big question is, did it actually work? Well, the researchers didn't just guess. They put Agent0 to the test against the original AI on a whole bunch of standardized tests. Let's check out the report card. All right, so first up, the math benchmark. Look at these numbers. The original model, it scores a 78. Okay, not bad. You give it some tools, and it gets a tiny little bump to 79.2. But look at Agent0. After going through its own little self-training boot camp, it jumps all the way to 82.4. That's a huge leap in math skills. But here's what's really cool. It's not just getting better at math. On MMLU Pro, which is the super tough test of broad knowledge, we see an even bigger jump. The base model is at 51.8. Agent0 skyrockets to 63.4. This shows that the skills it's picking up aren't just for one thing. They're actually making it smarter across the board. And when you look at the big picture, the average for general reasoning, it's the exact same story. Agent0 just consistently blows the others out of the water. This self-training loop is clearly, undeniably working. So, if you take one number away from all this, make it this one: a 24% boost in general reasoning. And remember, this was all achieved without a single new piece of data from a human, just by letting these two AI bears teach each other. Okay, so this brings us to the real so what of all this. Because honestly, this goes way beyond just getting better scores on a test. This has some massive implications. Remember that big problem we talked about at the start, the human bottleneck? Well, Agent0 shows us a way out. This is a path to an AI that can literally pull itself up by its own digital bootstraps. One that can create its own lessons, find its own weaknesses, and improve itself, all on its own. And that leaves us with this one kind of mind-bending question to chew on. Once an AI can genuinely teach itself and explore ideas that go way beyond anything we ever fed it, what's the first thing it's going to figure out that we just don't know yet? What's the first discovery it'll make that no human has ever even thought of?